So what are we doing?
Well, it's all here in the script.
In the script?
I'll let you borrow it.
Oh, cool. Script. I had a script before and... Wait, it's all completely irrelevant, it's just pictures
I
from
should
Daily
have mentioned, shouldn't I? As a random book and we don't have a script.
Oh yeah. We don't do scripts.
No.
Not for this, anyway. We are doing a script, but
For a musical.
Yeah,
that's people singing though.
it's not quite the same. So
Oh,
oxidation and
nice.
reduction. Yeah, cool. So we keep talking about NaCl and MgCl2, but
Lots
why
of
actually
formulas.
are they those numbers?
Well, that's what this is all about. Up here, we've drawn a beautiful periodic table.
It is lovely, nearly as lovely as Wayne's tree.
And up on this end, you've got, as I'm sure you're aware, the noble gases.
Yeah, these are all ones in nice ties and the royal of the periodic world. And these are sorted for life. They're ready. They're already reacted. Well, they don't need to react. They have 8 electrons in their outer shell, completely stable.
So, what all these others want to do is be just like these kings and queens. They want to be stable in their outer shell.
They do. And these are the halogens, so fluorine, chlorine, iodine, acetane and stuff. They have 7, and they want 8, so they could lose all 7, get to the next shell and have 8, or they could just gain 1.
Yeah.
And that's what they do, that's way easier.
But electrons are negatively charged.
They are negatively charged away, and that means it must be a -1.
Because they're going to gain one negative thing.
Then we go back one more, and we get to oxygen. And this is a similar thing, but it's got 6, so it wants to gain 2 more, so it gets -2.
Then you've got your nitrogen,
Same thing,
-3.
-3. But then we hit carbon, and it is -4.
That's the same as +4, because
It
they're
is.
in the middle.
So it sometimes does one, sometimes the other, depends how it feels.
So if we go over to the other side and then work our way back, we're going to have...
We have
lithium.
group 1, which has 1 electron in its outer shell, so it could gain 7 electrons, but it doesn't do that.
Instead, it will lose 1.
As
It's
there.
losing a negative thing, it's going to become positive.
Yes.
Then you've got magnesium and calcium.
It will follow a similar theme, this becomes +2, and this becomes
Plus boron and stuff.
+3. Now, this is about to make sense. When compounds react, they want to reach an oxidation number of 0. That's what they want in life. So, this is why we react NaCl. When NaCl is made, it is just
Na is
NaCl.
+1, Cl is -1. So overall, it's going to be 0.
That's what you want, and that's why MgCl2 is MgCl2.
Mg is 2+, each Cl is minus, so you're going to need 2 of them to make it 0.
And this is really handy, not now, but when you see transition metals, because they're pretty funky. Sometimes they'll be +1, sometimes they'll be +2, +3, all the way down to the minuses. They just change depending on what experiences they're being put into.
So, because they're unknown, but these things are all constant, when you put them together you can work out what it is in that particular example.
You can. So if we had something like CuO3, they like using copper and cobalt. Yeah.
Copper is unknown because it changes. It could be 1, 2, 3, 4, 5 or 6, any of those pluses.
It could be.
But oxygen we know is 2 minus.
We do, and there's 3 of them, so if there's 3 of 2 minus, it must be -6. And we want to get to 0, so it doesn't take genius to work out, it has to be +6.
So in that particular example, copper would be +6.
It would be, and this is the sort of question you get in an exam just to check your understanding of oxidation and reduction, but I don't think it ends there, Wayne.
Unfortunately, Triv, you're right, it doesn't end there. If you rub it all off, it goes on to reactions.
It does.
To take it to the next step.
And oxidation and reduction as things. So you might remember in GCSE you encountered things called oil rig. Now, oil rig is an acronym.
Yep. It stands for oxidation is loss of electrons, reduction is gain.
And in an exam they might ask you to label something in a reaction. Like this reaction here, it'll say what has been oxidised and what has been reduced. So as oxidation is the loss of electrons, that's what magnesium has done, so oxidation to magnesium has been oxidised.
And the reason for this is when they're on their own, they are 0, they are neutral. So chlorine, although it's bonded to another chlorine, it's not bonded to anything else, it's 0.
And when it gets to the compound, they split into their things, so Mg becomes 2+, and each chlorine becomes 1-.
As I just explained before, that's going to be overall, it's going to be 0, but when you notice the change from one side to the other, then you can apply oxidation and reduction.
You can, and that's why I skipped ahead a bit earlier. So magnesium has been oxidised because it's lost 2 electrons each. Chlorine has been reduced because it has gained electron each. But they don't just finish there. Sometimes they ask something else to try and confuse. They ask which has been the reducing agent and which has been the oxidation agent. And this is the other way around, because the agent is the one that has caused the change. So magnesium is the reducing agent because it's caused chlorine to be reduced, and chlorine is the oxidising agent because it's caused magnesium to be oxidised. Bit of a mouthful.
That was very well said there.
Thank you.
So, this is a redox reaction.
Yeah.
What on earth does that mean?
Well, Wayne, it was when both oxidation and reduction has happened in the same reaction, because it doesn't always, sometimes just one of them.
Now, I read ahead and I've heard of this thing called disproportionation.
Oh, that sounds saucy.
And oxidation and reduction both happen in there.
Mhm.
So what's the difference between that and redox then?
Well, they both happen to the same species, that means the same element.
Because in this case, magnesium's been oxidised, chlorine's been reduced. If I find an example, can the oxidised and reduced both happen to the same element?
They can.
Rip us off, I'll find an example.
That sounds like a great plan. It does sound a little confusing, but it does both happen. They do make 2 separate compounds, and that's how it does it. So, example time.
Ready.
Brick.
CO2 plus water. Apparently, I've had rumours.
Little bird has told us
It's
that.
HClO plus HCl.
So this is where we need to start annotating with our oxidation numbers. So here, Cl is on its own, so it's 0. Here we've got +1 for each one of these and 2 minus. Here it's similar, +1, I'm going to leave out the chlorine for now, and 2 minus. And here, +1, and again the chlorine is the mysterious one, because it'll say which is being disproportionated. You guess it's going to be chlorine, but why?
Well, for this to equal 0, in this particular example, chlorine must be -1.
It must be.
And in this case, it's oddly taken the form of +1.
Oh, that's funny.
So, hydrogen hasn't changed. It's +1 here, and it's +1 here, and it's +1 here. Oxygen is 2 minus and 2 minus, but chlorine's both gone up to +1 and down to -1.
So in your exam you'll have to write that chlorine has been oxidised and say where. So you'll say it's gone from a oxidation number of 0 to an oxidation number of +1. And then you have to say it's been reduced as well, therefore it has been the species that has been disproportionised. I think that's the thing.
That's not oxygen, that's 0. It's an oxidation number of 0 to +1 and from 0 to -1.
So it does happen.
That's the same thing's been both. It's a, what's it?
Disproportionation reaction.
So I have to say, what? Hopefully you understand and you're not going, what?
Because if you are, you'll have to ask us a question in the comments below or on our Facebook page.
Yep. And that's pretty much it for this entire part.
It is, and there's one last thing I'm going to mention before we go.
So we'll see you at the next video.
Yeah.
Something about defining?
Yeah, definition.